Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges, and my courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam exam, Tifr, Jest, and other exams related to physical science. Okay, and also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my live free classes, uh, which are going to help you to crack the examinations related to physical science. Okay, so today I'm going to solve June 2019 CSIR NET physical science question paper. Okay, so this is going to be series. So first I will solve 2019 CSIR NET physical science paper, then 2020 and 2021 and so on. Okay, so this is the series number 1 for 2019 paper. Okay, so I'm going to start now. I'm going to start with the question number first. Okay. Meanwhile, just let me check. Am I audible or not? Okay. Just let me check. Okay. Yeah, I'm audible now. Okay, guys. So I'll start with question number first. So this is June 2019 question paper. Okay. Okay, and this is the question of part B. Okay. The question is, and it is the question from classical mechanics. Question is, an object is dropped. Very good question. Object is dropped on a cushion on a cushion on a cushion from a height from a height from a height from a height 10 meter 10 meter above it. On being hit on being hit the cushion is depressed cushion is depressed by 0.1 meter, assuming that the cushion provides the cushion provides a constant resistive force a constant resistive force the deceleration the deceleration the deceleration of the object deceleration of the object after hitting the cushion after hitting the cushion in terms of the acceleration in terms of the acceleration due to gravity g is options are given 10g, option B is 50g, option C is 100g, and option D is G. Okay, so this is the question. Okay, I'm going to solve it now for you. The deceleration. Okay. So question is, an object is dropped on a cushion from a height 10 meter. Okay. So we have dropped object which is from height 10 meter. Okay. And we have dropped it on a cushion. Okay. On being hit, the cushion is depressed by 0.1 meter. Then as the object hits the cushion gets depressed by 0.1 meter. Okay. Assuming that the cushion provides a constant resistive force. Okay, cushion is providing constant resistive force. The deceleration, okay, the deceleration of the object after hitting the cushion in terms of acceleration due to gravity. Okay, so you need to find out deceleration. Okay, deceleration. This is nothing but acceleration, but in opposite sign. Okay, okay, okay. So we need to find out deceleration of the object. Okay, and in terms of g we need to find out. Okay, very simple question and very good question. Okay, so I'll solve now. Meanwhile, I'll check the network. Is it working? Yeah, it's working fine. Okay, so I'll explain it. Like this is the object. We have thrown this object. Okay, drop this object from height h. Okay, this is the cushion. Okay, this is the height h equal to 10 meter is given. Okay, this is 10 meter and this is the cushion, and this cushion gets depressed by 10 meter. Okay, 0.1 meter, 0.1 meter. Okay, this is 0.1 meter. This height cushion gets depressed. Okay, so this is the one. Okay, zero point zero 0.01 meter. Okay, this is the depressed cushion. Okay, depth of the cushion, because it gets depressed by the object. Okay, so what we are going to do is, for that, first we'll get the velocity of the particle just before hitting the cushion. Okay, what will be velocity? So for that, we can you can do we can do it by equation of motion, as well as we can do from the conservation of energy as well. Okay, so for equation from equation of motion, we can get it like this. Okay, so we know v square equal to u square plus 2gs, right? 2gh, right? This equation we know. Okay, this is equation of motion. Okay, this is third equation of motion. Okay, so here initially its velocity is 0, right? So v square is going to be 0, and plus it is going down, right? So g will be plus, okay, 2g, and h is 10, height is 10 meter given, right? So it means v square is going to be root 20g, right? Sorry, v equal to root 20g, v square equal to 20g, and v equal to root 20g. Okay, so this is one. The same thing we can also find out by conservation of energy as well. Okay, conservation of energy means the energy at the top is that potential energy as top is going to be equal to the kinetic energy. Okay, just hitting the this cushion. From there also we can find out. I'll show you, like mgh, conservation of energy. Okay, conservation of energy. So this is going to be mgh, the energy, the potential energy of the particle, right? Which is at height h. Okay, this goes mgh, right? And potential energy, the kinetic energy of the particle just before hitting the cushion is going to be half mv square, right? Get cancelled, and this is going to be v square equal to 2gh, and that is 2 into g, h is 10, right? That is 20. From this method also we can find out. I have told you both methods. Okay, so we have got the velocity. We have got the velocity of the particle, or velocity of the of an object just before hitting the cushion. Okay. Well, now we will use that second law of the motion, right? That Newton's second law of motion that we know. Okay. So this we know, right? Since we know dp upon dt, that is change of momentum, is going to be equal to that mass because of this object, the cushion gets depressed by 0.1 meter, right? So this is going to be, we will use this equation. Okay, second law of motion, right? dp upon dt, where p is the momentum. Okay, dp upon dt is going to be mg. Mg is going down minus k. K is the that constant resistive force, right? Because the cushion is also opposing the object motion, right? Okay, this is the force. Because cushion has constant resistive force. Let that constant resistive force is k, right? So this is the equation of motion, right? Equation of second law of the motion, you can say. So dp upon dt equal to mg, which is the m is the mass of the object, g is the gravity, right? Okay, acceleration due to gravity. Okay, right? So this equation of motion we are going to use, this is, and because of the resistive force, that is k, because this is constant, which is given right here. assuming that the cushion provides a constant resistive force. Okay. Now we can write this like that, mv dv upon dt, right? Because since we know P equal to mv, momentum equal to mass into velocity, equal to going to be mv minus k. This also we can write like this, m into dx upon dt into dv upon dx. We can write it mv minus k. This is very important step, guys. Okay. So what I have done, I have multiplied by dx and divide by dx. Okay. Why I have done it? Because this is very important step. If you know this step, if you understood this step, then you will be able to solve this question easily. Okay. Yes. Okay. This one. So this. So I have done just, I have multiplied by dx and divide by dx. So we can do it, right? So now this equation is going, dx upon dt is going to be v, right? So this is going to be mv, and this one is dv upon dx, right? This we can write dx upon dt is v, right? Since we know dx upon dt is velocity, right? Okay, so we'll write mv dv upon dx. Okay, and this is going to be equal to mg minus k. Okay, or we can write m, we'll take m in right hand side, so this is going to be v dv upon dx. So this is going to be m will go here, so g minus k upon m. Okay, or we can write like this, v dv dx will go here. Okay, so this is going to be dx. Okay, this step is very important step, guys. Okay, because this equation we know second law of motion. Okay, if this force is equal to this force. Okay, well, so now we can integrate it, right? It is going to be integration v dv equal to integration g minus k upon m, okay, dx. Limit is going to be, you need to understand limit here. Okay, so the velocity, you can see that the velocity, yeah, you can see the velocity here. Okay, if you see here velocity, the velocity just before hitting the cushion, right? We have already find out that is v equal to this, and after hitting this, this cushion will get depressed, right? Get depressed by 0.1 meter. Okay, after that, that velocity of this particle is going to be 0. Okay, right? And then it will decelerate. Okay, okay, so limit is going to be root 2g, root 20g, root 20g to 0, because after hitting the as it will hit, and it will go to 0.1 meter, at that time velocity will become 0. After that, object will deaccelerate. Okay, okay, okay. So this is the limit. Now you can see here limit. The limit is very, to understand limit is very important, guys. Okay, so you can see the cushions get depressed by 0.1 meter, right? So we'll measure height from bottom to top, right? So this is going to be this height is here is 0, here 0.01, right? So we'll write limit here like this. the limit is going to be 0.1 to 0. Why? Because it is going down, right? So we measure the distance from bottom. This is 0. This is this point is from here. The distance from here to here is going to be 0.01, right? Have you make any mistake? Let me check. Okay, yeah. This is not. This is 0.01, guys. 0.01 meter. Okay, 0.01 meter. 0.01 meter. Okay, so this is going to be the limit is going to be 0.01 to 0. This step is very important, guys. Okay, so I hope you understood it, right? So the velocity limit is very easy to understand, right? The velocity before hitting the cushion, just before hitting the cushion is this, and after hitting the velocity will become 0, right? So that's why we have taken limit root 20 g to 0. Similarly here for cushion gets depressed by 0.1 meter, right? So in that case the limit is going to be, because if you measure from bottom to up, so it is going to be like this part is going to be 0 and this part is 0.1, right? So that's why the limit is going to be 0.1 to 0. Very important step, guys. Okay, this one. Okay, let me just check. Okay, okay, so now we'll solve it. So this is very simple integration, so it is going to be uh, we'll integrate it. So it is v square by 2 integration to 20g to 0 is going to be g minus k upon m, this one, g minus k upon m, and this is going to be x, and limit is going to be 0.1 to 0. So this is going to be minus root 20 g minus root 20 g upon 2 is going to be g minus k upon m, and this is going to be 0.1, right? This will be minus, right? Because this limit are used. Minus will get cancelled. Okay, and this is going to be, this is v square, right? V square value is going to be, v is the value, so v square value is going to be minus 20. Okay, minus will get cancelled. Okay, and this is going to be 10g upon 0.1 equal to g minus k upon m, right? This implies g minus k upon m. This is the deceleration. Okay, and this is going to be this. This is 0.1, 0.1. Okay, So this will be 100 G. Okay, this is the answer. Okay, so which option is matching? Let's check. So option number C is the correct one, guys. Okay, so option number C, 100 G. Okay, so very good question, guys. And okay, so we have used that equation of motion, and then the second law of Newton's second law of motion. Okay, very important question. So this is done. Now question number 2. Question number 2. These are section B questions. Okay. Okay. Next question is, this is also very good question. A turntable is rotating. Turntable is rotating with a constant angular velocity with a constant angular velocity omega naught in the rotating frame fixed to the turntable fixed to the turntable okay, a particle moves radially outwards at a constant speed at a constant speed v naught. The acceleration of the particle acceleration of the particle in the r theta coordinates r theta coordinates as seen from an inertial frame from an inertial frame, the origin of which is at the center of the particle, center of the particle, center of the turntable, okay, center of the turntable is. Options are, option number A is minus r omega naught square r cap. Option B is 2r omega naught square r cap plus v naught omega naught theta cap. Option C is r omega naught square r cap omega naught theta cap option C is r omega naught square r cap plus 2 v naught omega naught theta cap, and option D is minus r omega naught square r cap plus 2 v naught omega naught theta cap. Okay, these are the options. Okay, very good question. So question is, a turntable is rotating with a constant angular velocity. Turntable is like in the shape like that is CD, right? CD like this, turntable like this, turntable. Okay, like CD, we have CD, DVD, right? In this shape, okay, turntable. So a turntable is rotating with constant angular velocity omega naught. So velocity of turntable is given, that is angular velocity is given omega naught. Okay, in the rotating frame fixed to the turntable. Okay, from the rotating frame means from turntable. Okay, in the rotating frame a particle moves radially outward. Okay, so this is the turntable. Okay, this is moving with angular velocity omega naught. Okay, this is the turntable moving with angular velocity omega naught, and there is a particle which is moving radially outward. Okay, moving radially outward. Okay, so now at a constant speed. Okay, speed is constant v naught. Okay, with the speed of v naught. Okay, so next is the acceleration of the particle in the r theta coordinates. So you need to find out acceleration of the particle in the r theta coordinate. Okay, they will mean r and theta coordinates as seen from an inertial frame, means as seen from the frame, rotating frame. Okay, inertial frame. the origin of which is at the center of the turntable, and the origin of that frame is at the center of turntable. Okay, here. Okay, this is the origin. So that's what is given. So very good question. Okay, I'm going to solve now. Okay. So there is a formula, guys. You need to note down and memorize it. Okay, by practicing questions. The formula is the acceleration in polar coordinate. Okay, the acceleration in polar coordinate. So acceleration in polar coordinate. Polar coordinate. Polar coordinate. We know this is A. That's what we need to find. A r cap plus A theta cap. Okay, very important formula. So any acceleration in so that is what asking, right? The acceleration of particle in r theta coordinates means in polar coordinate we need to find out the acceleration. So this is the one. A equal to r cap plus A theta cap. Okay, where the value of AR equal to r double dot minus r theta dot square. Okay, r double dot minus r theta dot square. Similarly, A theta, the value of A theta is r theta double dot plus 2 r dot theta dot. Okay, so this is the formula you need to note down. Okay, r cap, theta cap, and the AR value is r double dot minus r theta dot square, and A theta value is r theta double dot minus 2r dot theta dot. Okay, so we'll put the value here. Okay, so this is going to be, since we have been given this one, angular velocity of this turntable is given. Okay, angular velocity means, since theta dot is given, okay, theta dot is given, angular velocity means theta dot, right? Theta dot is given omega naught, and the speed of particle is also given. Okay, speed of particle given, that is r dot is given v naught. Okay, so we'll put the value here. So value for A is going to be, AR value is r double dot. R double dot means this is omega naught. This is r dot, right? R dot is this, r double dot, because v naught is constant, so r double dot is going to be here. R dot double dot is going to be 0. Okay, minus, because we are putting value of AR. Okay, so minus r will remain as a theta dot square. Theta dot value is omega naught square. Okay, then r cap. Okay, plus the value of A theta will put, A theta is this value, right? R will remain here, and theta double dot is going to be 0. So this value is going to be 0, because omega is constant, right? So if we differentiate again, so theta double dot is going to be 0 because the omega naught is constant. Okay, this is 0 plus 2. R dot value is v naught, and theta dot value is omega naught, right? So this is going to be, so then value of A is going to be, minus r omega naught square r cap, this is 0, right, plus 2 v naught omega naught. Okay, this is the answer. And which option is matching? Minus r omega naught square r cap, minus r omega naught square r cap, plus 2 omega plus 2 v naught omega naught theta cap. This is theta cap, right? Okay, this is theta cap. Okay, so 2 omega v naught omega naught theta cap. Okay, so which option is matching? Option D is matching, right? This is the correct answer. Okay, next question, question number 3rd. Question number 3rd is, this is also a very good question. Assume that the earth revolves, revolves in a circular orbit, in a circular orbit around the sun, suppose the gravitational constant g, the gravitational constant g varies slowly as function of time, as a function of time, in particular it decreases to half of its initial value, half of its initial value in the course of 1 million years. In the course of 1 million years, then during this time, During this time, the options are option A, radius of the Earth's orbit, radius of the Earth's office, Earth's office, sorry, Earth's orbit, radius of the Earth's orbit will increase, will increase, will increase by a factor of 2, by a factor of, by a factor of 2. Option B is total energy of the Earth remains constant. Total energy of Earth remains constant. Remains constant. Option C is orbital angular momentum of Earth. Orbital angular momentum. Angular momentum. Orbital angular momentum of the Earth. Of the Earth. Of the Earth. Of the Earth will increase Option D is radius of the Earth orbit. Radius of the Earth's orbit. Earth's orbit remains the same. Remains the same. Okay. So this is the question. So question is, assume that the Earth revolves in a circular orbit around the sun. Okay. So we need to assume that Earth is rotating around the sun. Suppose the gravitational constant G varies slowly as a function of time. Okay, so it is given that G is varying slowly as a function of time. In particular, it is saying in this case, in particular, it decreases to half of its initial value. So it becomes half of initial value in the course of 1 million years. So in the 1 million years time duration, the G becomes half of its value. Okay. Then during this time, the radius of the Earth's orbit will increase by factor of 2, or the total energy of Earth remain constant. Option C is orbital angular momentum of the Earth will increase, and these radius of the Earth's orbit remains constant. So we need to find out which option is. We need to select the correct option. Okay. Very good question. So first, okay, I'm going to solve first. So here G is given. G is given. G is function of T. Okay, this is given because that varies with time. Okay. Okay. Next, let mass of sun is capital M. Okay. M is the mass of sun. Okay, capital M, and small m small m is going to is mass of earth, mass of earth. Okay, this is capital M. Okay, okay, and so we know it is a central force problem, guys. Okay, so angular momentum of the system will be conserved. Okay, because this is the orbit of earth. Okay, and earth is rotating, and at the center there is a sun. Okay, central force problem. Okay, earth is rotating about the sun. Okay, and mass of sun is m, capital M, and mass of earth is small m. Okay, and g is the gravitational constant which varies with time. Okay, okay, so now total energy of the system is going to be, for this system, total energy of this is the earth. Okay, this is earth, this is earth. Okay, which is moving around the sun. Okay, so total energy of the system is going to be, okay, just wait, guys. Okay, guys, so remaining class I'm going